Assalamualaikum warahmatullahi wabarakatuh and a very good morning to the panels. I am Adik Saifullah bin Azahari and today I would like to present my research paper, which is the study of vibration on ballast and non-ballast railway bridge. So for the table of content on my research paper that I would like to present, first is the introduction, next is the literature review, then the methodology, expected result, and lastly the conclusion. So for the research background, the railway bridge is used to transport the train across any obstruction such as waterways, mountain, and road. So KTMB as an operator which provide commuter service, electric train service, and freight train use this railway bridge to make sure the train across any obstruction. In KTMB, they own 654 railway bridges with different types, such as truss bridge, arch bridge, and concrete bridge. Also in KTMB, they have two types of track on railway bridge, which are ballast track and non-ballast track. However, most of the bridges had already been century old and some are at the end of their economic lifespan. So these bridges are regularly need to be maintained in order to keep their services for the train. And lastly, the vibration will be produced from the interaction of wheel and train when the train moves along the railway bridge. Next is the problem statement. The heavy traffic, weight of axle load increasing, and higher speed of trains are the factors that make the railway bridge become more fatigued and need regularly maintenance. Other than that, the vibration that being produced along the railway bridge when the train move also can be a factor in which contribute to the regularly maintenance of railway bridge. In fact, the railway bridge must withstand the vibration that being produced to make sure that the train is safe to move along the railway bridge. This problem arises because of the effect of vibration are not being observed properly. Besides, the lack of study in order to measure the vibration when the train moves along the railway bridge are not being measured properly. And lastly, is to monitor the vibration on two types of track on railway bridge. For the significance of study, in order to ensure the safety of train and the railway bridge, the effect of vibration on the railway bridge is going to be minimal. It also helps KTMB in determining which types of tracks on railway bridge can handle more vibration. Because of this action, it can help KTMB in reducing the maintenance cost for the railway bridge. Other than that, the passenger on the train can feel more comfortable and safer when the effect of vibration is minimal. And also the railway bridge will be more safe for the train to use. For the project objective, first is to investigate the potential parameter to measure vibration on railway ballast and non-ballast bridge. Second is to determine the vibration on ballast and non-ballast along the railway bridge. And third, to investigate the effect of vibration on railway ballast and non-ballast bridge when train move along the bridge. So for the scope of this project, it is focusing on the two types of track on railway bridge, which are ballast bridge that will be looked on plate girder and non-ballast bridge that will be looked on truss girder. Next, this project is going to be conducted to monitor and analyze the vibration that being produced when a train moving past along this bridge. So to determine the value of vibration on both types of bridge, this project will be using the pulse dynamic analyzer 16 channel. And also this bridge can be located in Klang Valley Double Track in Kuala Lumpur region. Next, for the literature review, the steel railway bridge are referred to a bridge where the entire superstructure is constructed of steel, distinguishing it from steel concrete composite bridge where the deck is reinforced by concrete slab. Also, a steel deck has the advantage of making it easier to fully inspect any component for short and medium spans, whereas post tension or reinforced concrete slabs make it challenging to check rebars and cables, in which this steel railway bridge is more easier to be inspected, so any maintenance or broken can be detected in detail. So for the types of traditional bridge that can be used to create steel bridge are plate type girder, box girder type, truss girder, arc type, cable supporting bridge, and deck plate. So in KTMB, the first railway bridge is the Pratt Truss Steel Railway Bridge, or being known as Pratt girder. The truss bridges are designed by combining relatively small structural members into a series of interconnected triangles. A straightforward web arrangement of vertical in compression and diagonals in tension, known to be the Pratt truss. As you can see on the picture on the right side, which is the Pratt truss steel railway bridge, they are no-ballast track. Next is the plate girder railway bridge that located in KTMB, which are truss through. The plate girder used two I-shaped girders and side cantilevers as their primary structure for span up to around 40 meters. As you can see on the left side where the plate girder design, the track that being used are ballasted track. Next is the vibration on railway bridge. When a train moves across a bridge, it will produce vibration because of the interaction of wheel and rails. Besides, the vibration will amplify if there are different surfaces that being placed on the rail. As for example, the different type of track on the railway bridge, such as ballast track and non-ballast track, will give different outcome in terms of vibration. In fact, the bridge structure must withstand the vibration that are being transmitted from the rail to the bridge, so that the railway bridge are safe to be used for the train. Next is the ballast track. Ballast can be molded by a series of spring and damper, which reducing the vibration from the interaction of wheels and rail. The inherent advantage of the ballast track are typically related not only to noise and vibration reduction, but also to decreased maintenance expenses. As you can see in the figure, the ballast track arrangement of the railway bridge, where below the rails and slipper there are a formation of ballast. So when the vibration is produced, it will firstly go through the formation of ballast before being transmitted to the bridge deck. Next, the non-ballast track steel bridge with No ballast railroad is being put above wooden sleeper with hard rail pads due to the softer rigidity of the wooden sleepers that being compared to the concrete sleepers and the better damping efficiency of wood. This will cause the vibration of the wheel-rail interaction to be led to the bridge structure. In the figure of wheel-rail interaction, when there is no ballast formation or track for the non-ballast track, the vibration from the wheel-rail interaction will directly transmit to the structure of the bridge. Next, in the methodology, I will explain how to determine the vibration on railway bridge. So firstly, the vibration that being produced by a moving train along the railway bridge will be measured by using the pulse dynamic analyzer 16 channel. Also, this method will be used on the two types of track which are ballast track, that is flat girder, and non-ballast track which is flat thrust girder. To determine the vibration, there will be a testing that on this bridge that are located in Klang Valley Double Track in Kuala Lumpur region. So on how to measure the accurate data for the vibration on the rail bridge, the pulse dynamic analyzer will be placed at the rail barrier which is located below the rails. This can take the maximized or maximum value of vibration that being produced when a train are moving along the railway bridge. And the parameter that will be used to measure the value of vibration in this research study are the amplitude and its frequency. So next, for the testing and data collection, to measure the value of vibration between these two types of bridge, as I said earlier, it will be a testing will be conducted by using the pulse dynamic analyzer 16 channel. So from the data collection, the value of vibration from the ballast track and non-ballast track railway bridge can be compared and analysed in terms of its frequency and amplitude. So this study can determine which types of tracks on railway bridge that will give the most value of vibration. And for the data analysis, the value of vibration that being produced by train travelling over the rail bridge through two types of tracks can be determined by using the value of amplitude and frequency. Low amplitude and frequency value will indicate that the vibration energy is low because it has gone through the ballast profile so that the bridge structure can withstand the vibration. And for the high amplitude and frequency value are a signal for vibration energy that will be directed to the bridge structure. So next, for the expected result, this study can determine which railway bridge is better and more effective for KTMB. As this study is going to analyze which bridge will produce more vibration according to the parameter that had been chosen, we will know which type of track on railway bridge that will produce more vibration. So lastly, this expected result will show a comparison between the ballast track and non-ballast track on the railway bridge. So for the conclusion, the main findings of the case study of the vibration on two types of track on railway bridge, which are ballast track and non-ballast track, comparing and determine the vibration between the bridge for seeking to improve the reliability, maintainability and safety of the railway bridge itself. Thank you.